Hello and Assalamu alaikum. We are from Group 5, and in this video we will be presenting to you about particle physics. Before we dive deeper into this topic, I will talk about the introductions of particle physics in order to let you to be able to imagine about particle physics in a big picture before we continue to know about the theory, applications, and so on. So, particle physics is a branch of physics, obviously, which studies about the nature of particles, which consist of matter and radiation. The word particle, without physics, could be referred as various small objects, such as protons, neutrons, or even household dust. But particle physics is the study of fundamental particles and their interactions in nature. Particle physics isn't the content to study the microscopic world of cells, molecules, atoms, or even quarks, but it is about the physical processes that occur at scales even smaller than atomic nuclei. At the same time, it engages the most profound mysteries in nature, as an example of how did the universe begin, what explains the pattern of masses in the universe, why is there more matter than antimatter in the universe, why are energy and momentum conserved, and how will the universe evolve. So, in order for us to understand deeply about the answers of these questions and about particle physics, we will now move on to the theory.
Boson. In quantum mechanics, a boson is a particle that follows Bose-Einstein statistics. The name boson was coined by Paul Dirac to commemorate the contribution of Satyendra Nath Bose, an Indian physicist in developing Bose-Einstein statistics with Albert Einstein, which theorized the characteristics of elementary particles. Examples of bosons are fundamental particles such as photons, gluons, W and Z bosons, and the more recently discovered is Higgs bosons. An important characteristic of bosons is that there is no restriction on the number of them that occupy the same quantum state. Bosons may be either elementary, like photons, or composite, like mesons. Next is Higgs bosons. The Higgs boson is an elementary particle in the standard model of particle physics produced by the quantum excitation of the Higgs field. In the standard model, the Higgs particle is a massive scalar boson with zero spin, no electric charge, and no color charge. It is also very unstable, decaying into other particles almost immediately. It is named after physicist Peter Higgs, who in 1964, along with 5 other scientists, proposed an Higgs mechanism to explain why some particles have mass. This mechanism required that a spinless particle known as a scalar boson should exist with properties as described by the Higgs mechanism theory.
Did you know that all ordinary matter, including every atom on the periodic table of elements, consists of only 3 types of matter particles: up and down quarks, which make up the protons and neutrons in the nucleus, and electrons that surround the nucleus? The complete standard model took a long time to build. Physicist J. Thomson discovered the electron in 1897, and scientists at the Large Hadron Collider found the final piece of the puzzle, the Higgs boson, in 2012.
Hi and good evening. My name is Siti Nurhazwan Liana Ismail, emergent number 205913. And now I present about the theory of particle physics. The theoretical particle physics is attempt to develop the models, theoretical frameworks, and mathematical tools to understand current experiment and make prediction for future experiment. There are several major efforts being made in theoretical particle physics today. One important branch attempts to better understand is standard models and its tests. The standard model of particle physics is scientists' current best theory to describe the most basic building blocks of universe. It explains how particles that's called quarks, which make up protons and neutrons, and leptons, which includes electrons, make up all non-matters. It also explains how fast-carrying particles which belongs to a broader groups of bosons, influence the quarks and leptons. The standard models explain three of four fundamental forces that govern the universe: electromagnetism, the strong force, and the weak force. Electromagnetism is carried by photons and involves the interaction of electric fields and magnetic fields. The strong force, which is carried by gluons, binds together atomic nuclei to make them stable. The weak force carried by W and Z bosons causes nuclear reactions that have powered our suns and other stars for billions of years. Each group of quarks and leptons consists of 6 particles, which are related in pairs, or we call it generations. The first generation is the lightest and most stable particles, whereas the heaviest and less stable particles belongs to second and third generations. All stable matters in the universe is made from particles that belongs to the first generations. Any heavier particles quickly decay to more stable ones. The 6 quarks are in pairs in 3 generations, which is up quarks paired with down quarks, from the first generation, followed by chump quarks and strange quarks, and then the top quarks and bottom quarks. Quarks also comes in different colors and only mixed in such ways as to form colorless objects. The charge of quarks is different for every quarks, but the spin of each quarks is the same, which is half spin. The 6 leptons are similarly arranged in 3 generations: the electron and the electron neutrino, the muon and the muon neutrino, and tau neutrino. The electron, the muon, and the tau have an all-electric charge and a sizable mass, whereas the neutrinos are electrically neutral and have very little mass. So that's all from me. I will pass to the next presenter to continue the theory of particle physics for bosons. Thank you.
As we already know, particle physics is the study of the universe and the things that inhabit it by studying its smallest component, which are subatomic particles. But if you cannot see these particles, why should we care? This can be seen that when gas prices, electric bills, and also food prices are going up. What do they have in common? It is energy for our home, car, devices, and even forests. What is the relation of particle physics? Why does particle physics matter? It is because particles are energy. If you understand energy at the most fundamental level, you know that the gas, electricity, or even foods together to be energy. It enables us with the science to solve the next energy crisis. Over the last century, particle physics has definitely benefited from astronomy. In the earlier 20th century, cosmic rays were used to discover antimatter as well as the first completely new particles, muon and strange quark. As the sun fuses nuclei, it emits countless number of ghostly neutrino particles. Studying this led to discovering that they have tiny masses, but particle physics has also given back. Without particle physics, we could not explain how stars burn in the first place. So, what good is particle physics? Particle physics is important to understand some of the most dramatic events in the universe, such as supernovae. And lastly, learning about particle physics helps us to understand the world around us. The smallest distance, the highest energy, and also the earliest times.
Today, I'm going to share with you guys what is the application of particle physics. So, the application of particle physics is transportation. For example, maglev train. Magnetically levitating train use powerful superconducting magnet to suspend and propel the train. Maglev train are fast and quiet compared to wheeled mass transit system, potentially reaching velocities comparable to jet aircraft. The superconducting magnet technology developed for particle physics will play a key role in the future of this model of travel. Then, another application of particle physics is in medicine, which is magnetic resonance imaging, MRI. Magnetic resonance imaging is a fundamental technology of medical diagnosis that use superconducting magnet technology that originated as a tool for physicists to accelerate proton to the highest energy in the world. MRI produce high-quality image of the inside of a human body based on the principle of nuclear magnetic resonance. At the heart of MRI technology are powerful magnets made of superconducting wire and cable. A cadre of experts in superconductivity, physics, engineering, material science, and manufacturing first developed this technology to build a Fermilab Tevatron, the world's first superconducting synchronotron.
Hi, my name is Muhammad Azakimi bin Rashid and my matrix number is 207961. Today, I will be presenting the relevance of the particle physics in our daily life. So, let's start. 1. MRI. MRI is one of the particle physics machines that used in medical and agriculture. In medical field, every hospital in each country is using this MRI scanner. Usually, it is used by doctors against their patients to identify or diagnose conditions that affect soft tissue, such as tumor, including cancer, soft tissue injuries such as damaged ligaments, joint injury or disease, spinal injury or disease, injury or disease of internal organs, including the brain, heart, and digestive organs. In agriculture field, currently, MRI is used in agriculture field, especially in food technology, to assess food quality. Inspection of food products from the harvesting to the marketing can be readily accomplished by MRI. It provides an unrivaled opportunity to better study foods and understand the dynamic interaction that occur during processing and storage. MRI is used at quality control systems for food, such as meat, fruits, and vegetables. 2. Cargo scanner. Particle physics that used in cargo scanning plays an important role in the industry. It improves safety to the industry. It prevented the entry of weapons or dangerous objects that may compromise the integrity of employees and visitors in enterprises and public institutions. It also used as scanner for lorries and containers. It allows entire vehicles to be scrutinized for narcotic, weapons of mass destruction, explosive, and other illicit acts in just seconds. This also allows one to see every detail of the load and ensure that there are no hidden objects on floors, tires, or hard-to-reach places in the vehicles. That's all from our group. Thank you.